This is an A-level Further Mechanics 1 question on momentum and impulse in 2 dimensions. A particle P of mass 0.5 kg is moving with velocity 4I plus 4j meters per second when it receives an impulse of magnitude 2.5 newton seconds. As a result of the impulse, the direction of motion of P is deflected through an angle of 45 degrees. Given that I is equal to lambda I plus mu j newton seconds, find all the possible pairs of values of lambda and mu. Okay, so I'm going to take the information that I've been given and draw a diagram. So I'm going to have something like this. I want to try and keep it fairly accurate. So this, it represents u. So this was the velocity before, 4, and I'm using 1 square per 1. It would carry on moving in that direction, but we've been told that it's been deflected through an angle of 45 degrees. So it's 45 degrees off of this path. Now it could be that it deflects 45 degrees and moves horizontally. Okay, I know it's going to be horizontal because this is going to be a 45 degree angle, because this down here is a 45 degree angle, and that's because the I and the j parts are the same. So I could end up going this way. Let's call that V1. There is another direction that I could go in. I could actually go straight up here. That's also a deflection of 45 degrees. We'll call that V2. And I know that's 45 degrees because this has to be a 45 degree angle here. So there are 2 possible directions that the particle move in after it's been deflected by through an angle of 45 degrees. Now I can see that if it's going horizontally, then there's no j component to the velocity, so I can write v1 as equal to some x value for I and 0, and v2, I could write that as, well, if it's vertical, it's going to be 0 and some value for the j component of its velocity. So I'm going to start by using the impulse momentum equation, which is this. The impulse, let's write that as I. Now I know the size of the impulse, but I don't know the impulse itself. Let's see if I can work out the impulse from the information I've got. So the mass is 0.5. V, now I'm going to start with V1 and have x0, and then minus u, which is 4. So minus 4 minus 4. So that will give me an impulse of x minus 4 over 2. So that becomes x over 2 minus 2 for the I part. And then for the j part, 0 minus 4 is minus 4. And then half of that is negative 2. Okay, now what can I do with this? Well, I'm told that the magnitude of the impulse is 2.5. In other words, I can write this: the magnitude of the impulse is 2.5. The size of the impulse is 2.5. In other words, if I do Pythagoras on this I part and j part, that's going to be equal to 2.5. So to do Pythagoras, it's going to be the square root of x minus or x over 2 minus 2 squared plus negative 2 squared is going to equal to 2.5. We'll start by squaring both sides. So I'll have x over 2 minus 2 all squared minus 2 all squared. So let's just work that out. That's going to be 4. So plus 4 is equal to 2.5 squared. Let's expand the brackets and simplify it. So x over 2 times by x over 2 is going to be x squared over 4. And then for the x terms, let's say I'll have minus x, so minus 2x. And then I'll get a plus 4. That's from expanding brackets. There's a plus 4 there already. And then I'll take the 2.5 squared across. So now I've got a quadratic, which will be x squared over 4 minus 2x, and then plus 7 over 4 is equal to 0. It makes sense to multiply everything by 4. So we're going to get x squared minus 8x plus 7 is equal to 0. That's nice and easy. I can factorize that without using a calculator. So x minus 7 and x minus 1 is equal to 0. So that gives me these x values. That will be the value that goes here as equal to 7, or x can be equal to 1. Now with those two values of x, what I'm going to do is now work out what the impulse could be. So let's start with x is equal to 7. So with x equal to 7, what I'll get here is impulse is equal to 0.5, and then it'll be 7 minus 4, 0 minus 4. So that'll give me an impulse equal to 7 minus 4, which is 3, and then divide by 2, so 3 over 2, and negative 2, that's what the bottom part will be. Okay, so this will give me lambda equals to 3 over 2, and mu equal to negative 2. Let's try now the x is equal to 1 and see what we get from that. So impulse will be equal to 0.5, but now it'll be 1 minus 4, then 0 minus 4, give me an impulse equal to, so the top will be negative 3, so it'll be minus 3 over 2. The bottom will still be negative 2. So this gives me lambda is equal to negative 3 over 2. Don't know what that is. It's meant to be a 2. And mu is equal to negative 2 again. Okay. Now, I could say, right, that's it. I'm done. But are there any other possible values for lambda and mu? And there are actually two more. I don't need to go through all this working again. But remember, I used V1 where I had x and 0. Now, if I had used V2, I'd have 0 here and y here. All of my working would look the same, except the values at the top and the bottom would be reversed, because the way I got these numbers was because I had x at the top and 0 at the bottom. So by using the other velocity, V2, these numbers would be the other way up. So let's just write that down over here, and we'll get our other two values. So using V2, I would get two other solutions, basically the same numbers but the other way around. So lambda is equal to negative 2, mu equal to 3 over 2, and then again these two numbers the other way around, because all my working would be basically upside down from what I've got, and that will be lambda is equal to negative 2 and mu is equal to negative 3 over 2. So there are actually four possible solutions, and I think it's probably very easy to not get these last two, or it might take a long time because you substitute in this 0y back at the beginning and run through all this working again. If we can sort of reason and think through what would happen, that will save us a lot of time, and it will save us having to basically do all of this working all over again. But here we go, our four different values or pairs of values for the impulse lambda and mu.